our knowledgeable student whom we sent for bachelor's. Then he proceeded to his master's and currently doing his PhD in Germany.
My degree in KTU was more focused on manufacturing engineering and stuff. So even though it was mechanical, every university has their own specialization, and KTU was more specialized in the manufacturing aspect. And then towards the end semesters, CAM was a very important topic that we had to do, which is computer aided manufacturing, which is basically the precursor to whatever you see today, which is like 3D printing and stuff. So that is the biggest advantage, I would say. And then the ability to do exchange semester in any other university. So I was lucky enough to get into DTU for 1 semester, which is one of the best universities in Europe as well. So, and then you get this international exposure, not only in terms of academia, but also, the international exposure in terms of people and culture and so on and so forth. You can never compare German universities like that. You have to look at what courses they offer and how proficient and how much funding they have in that particular course. And then you go to that university, right? And in that regard, TU Chemnitz's professor, who's my head professor for the PhD program, he was basically the R&D head, the technical director. He was the technical director of Volkswagen in China. And he has such a huge connection. So this guy is basically an engineer, very applied research scientist engineer. And then he came to the university and said, okay, now I'm going to do European projects. So this is the main reason. Always be curious, always keep learning. Money, don't search money. If you get a part-time job like me, when I was a research student in the institute, which is how I did my master's degree there, and I also got into as a full-time researcher, right? So if you get a part-time job which gives money, which also is technical and relevant to your field, then go for it. Absolutely, 100%. Don't chase money, chase knowledge. Always focus on yourself. Try to make yourself better, and then people will come to you offering money for your solution. I'm a scientist who's also doing a PhD, and I'm also working on real-life projects, European projects. So the idea is every year we have to do 1 or 2 courses to show that we are still improving, and this is important. And the funny thing is, even though I have so many degrees in so many courses in AI and stuff, I'm still doing courses on control engineering, for instance. This is the course I'm doing. And when you look at control, this is the basis of electrical and electronics, ECE basically. So this highlights the point again that without knowing the basis, you cannot go into AI. You need to have, looking at an engineering perspective, you need to have some concepts of electrical, some concepts of mechanical, some concepts of other engineering, and then you can add AI as a supplement, which is only a tool. So stay with the basic, but don't just study the basic. Add whatever you can from state of the art. Any degree which has mechatronic elements, electronic elements, electrical elements, embedded elements, engineering elements. Study that, but then make yourself relevant in that state of the art, which means that even if the university is not offering courses, you have to have the knowledge to pursue, okay, what is the state of the art? Look, there's so many courses available online. There's so many state of the arts. There's so many talks about how the technology is developing. So update yourself.
Hello everybody, welcome all of you. My name is Shivaraman, Director of Europe Study Center. Today we are going to interview one of our super successful student and also our knowledgeable student whom we sent for bachelor's. Then he proceeded to his master's and currently doing his PhD in Germany. Tanuj, welcome to the show.
Hi Shivaraman, it's been a long time. How are you doing?
I'm good. Thank you so much to find time to do this interview. So kindly introduce you to our audience.
So I'm Tanuj. And I started my bachelor's in Kaunas Technical University, KTU, with the help of Shivaraman. And then I did like 4 years there. And then I also had an exchange semester Erasmus program, which is basically an exchange university, which I did in Denmark. And then I took a 1-year sabbatical. Once I was done with my program, I went back to India and then did a couple of internships, basically got to know the lay of the land on how the employment opportunities and all of them were. And then I reapplied for master's in TU Dresden. And then I studied computational modeling and simulation here. And then about 2.5 years ago, I completed my master's program. And I've been working in Fraunhofer, which is a scientific institute, as a researcher. And just last year, I also started my PhD while I'm also simultaneously a researcher. And my PhD is currently with TU Chemnitz. And then my field of research is basically alternative propulsion technology, specifically fuel cell hybrid electric vehicles. So I pretty much do my PhD's topic would be in the engineering aspect of it. So that's about it till date.
Super. Okay, you usually said that's about it, but it's quite a lot. So first to start with, I would like to tell the audience is like Tanuj's mother is my well-wisher, and she has guided me through a lot in my career, in my early days. Then once I remember Tanuj, she was approaching, I don't want to say the name of the university in Chennai for your admissions. I just asked your mom, Madam, kindly visit our office. Let's have a discussion. That's where your, what to say, first degree in Europe started. And I still remember when I met you first, as a 17-year-old boy with a lot of questions, and when you come with your mom and dad and you ask all these questions like a young aspirant youngster, and now looking at you doing your PhD, really happy. And first of all, congratulations for all your successes.
Thank you.
Start
I mean,
yeah.
I mean, it did start with you, so I'm also very thankful to you. That
I think major credit goes to your mom and you. Your mom took the decision and you made it count. That's what that matters end of the day. So first, let's start with your bachelor's. So for you to do a reputed, your research and your PhD in a top public university in Germany, the foundation should be really strong. So how did KTU, that is the bachelor degree, what you did, and how did it help in your foundation?
What I could say is one thing, of course, it was pretty much applied. So unlike the university where, because I can't speak for myself, but I can speak through some of my friends who did their bachelor's back in India and pretty reputed universities as well. So the idea is very simple. So you have pretty much close to zero applied knowledge. You've been doing the same curriculum for the past, I don't know, 15 years. They have the same stuff, the same thing. Nothing has changed. There's no state-of-the-art involvement, anything. And then when you look at, for instance, a European university and a public university, it's not the same way. What you will have is a curriculum which is updated. Of course, you will also study what has been done in the past, but then the end note of every course or every semester would always be something related to, okay, what's the state of the art and what's actually happening in the university. For instance, a very nice example, my degree in KTU was more focused on manufacturing engineering and stuff. So even though it was mechanical, every university has their own specialization, and KTU was more specialized in the manufacturing aspect. And then towards the end semesters, CAM was a very important topic that we had to do, which is computer aided manufacturing, which is basically the precursor to whatever you see today, which is like 3D printing and stuff. So that is the biggest advantage, I would say. And then the ability to do exchange semester in any other university. So I was lucky enough to get into DTU for one semester, which is one of the best universities in Europe as well. So, and then you get this international exposure, not only in terms of academia, but also, the international exposure in terms of people and culture and so on and so forth.
Okay. So Tanuj doesn't regret, when I spoke to your mom about your bachelor's and gave them options to Europe. So you don't regret that right now.
Absolutely not.
Thank you. Wonderful. So also, I always strongly tell people, if you may have a 100-acre university, cutting edge laboratories, facilities, and everything, but without qualified professors, you can never move forward. So your input about, the quality of professors that you had at the UG level.
I would say the professors were extremely applied. For instance, although my degree was more in the direction of manufacturing, I pretty much liked the simulation and the mechanics aspect of it. And I basically made close contact with the professor who was specialized in that. So I can also refer his name. His name is Kęstutis Vilkauskas. I'm pretty sure he's still the associate professor back there. And then he was, the thing is, they're very nice. They're very supportive. With the help of him, I was able to do 2 student conferences back in my UG level. And yeah, so you have a lot of support from the professors. One, they're very applied. They have a lot of industry experience, for instance. And the second thing is they're really supportive if you show the initiative. So if you're just going to the course and, just I'm doing the course for the sake of the course, then they wouldn't care much. But then if you show the initiative, they're always there to help you.
Super. Tanuj, you started with your discussion stating that, from my friends, I got to know, what happens back home in India. It's a world of difference, right?
Absolutely. And the funny part is I got to know this once I started doing my master's here in TU Tristan, because a lot of guys actually graduated from very good universities in Chennai. I'm gonna stay with you and I'm not gonna reveal the names because and then you see, even when you do the master's course, my master's course was actually one of the most challenging courses, actually. It's called Computational Modeling and Simulation. This involves applied mathematics, engineering, and computer science. All 3 of them pretty hard. And then you have to do a lot of technical stuff, like really a lot of technical stuff. And then you see a lot of my friends, for instance, they were able to manage through it, but then the time it took for them to get in there was much, much higher simply because they did not think about application. All they were thinking about was exams, how to clear them. So it's basically the schoolboy mentality, so to say. So yeah, to answer your question.
Yes, you're being, picture perfect and you're on the point, because we do these videos to create awareness, because and plus Tanuj, to look at the tuition fees that they spend in Chennai currently. This year, they are spending 7 lakhs per year tuition fees in some places, plus capitation, plus these, that, and all those things. Okay, let them spend. It's their money, Tanuj. Okay, we have no problem. But do we have qualified professors, experienced, dedicated professors? Do we have the laboratories? And most importantly, a university without an industrial connection, just for the namesake, running the programs and printing the degrees. I only look them as a giant size printers printing degrees.
Exactly. I mean, unless you're studying in IIT or NIT or IIIT or something like that, it does not make sense to actually.
Exactly. I still remember telling Tanuj, if not for NITs and IITs, always do your bachelor's, in top European public universities. And even in this digital era, people find it really difficult to believe 3-4 lakhs fee structure, they can study in European public universities. That's why we constantly keep creating awarenesses and all these things. And I strongly believe without excellent, dedicated professors, we can never impart high level of knowledge to the younger generation.
Absolutely.
Basically.
I do agree.
Yeah. So in bachelor's, you would have had some subjects which are really challenging, right? So how do you break those things, whether it's bachelor's or master's? How do you overcome those little challenges? Yeah.
It was more of the fact that it wasn't so challenging, because the funny part is since I do already like simulation and a lot of numerical stuff, the challenging subjects for my colleagues were actually pretty fun for me. And it was often the case that I was not interested in a particular subject, but I had to do it in order to, because certain basic subjects of course you can specialize. That was one of the nicest things. You can always specialize and somehow shape your degree the way you wanted to, but then you also had to do some basics, right? So for me, it was often the case that the basics, for instance, the basic in I don't know, like manufacturing or something like that, I wasn't a big fan of. So it was often the case that I wasn't that much interested, and then I had to do it. So that was the biggest challenge, not the technical aspect of it.
Tanuj, during your master program, I'm sure you would have had a lot of Indian students along with you. So was it surprising at times when they ask you some questions, then it made you feel like, why didn't you read this in your bachelor's? Did you feel so?
Absolutely, all the time, actually, because the thing is, even in our bachelor's degree, right? Just because we have to go through a certain curriculum, they basically ended up studying all these complicated formulas and formulations and stuff, but then they lack the very basic as to the essence of the question, like why would you want to apply this and what is the reason behind applying this. And most of the questions and formulations and tasks we have here in my master's program are related to that, where it's almost the case that you had to do the entire thing over, right? So without understanding the basics, it would be pretty much inevitable. So all the time to answer the question, yes, all the time. But then at the beginning, it was a bit shocking, but then not shocking, a little bit astounding, but then I sort of got used to it. But then we also did a lot of group sessions together. And then, yeah, the thing is, once I was able to explain it, they were able to grasp it pretty quickly, which basically gave me the hint that they had the knowledge, but just the way they've been guided, it's completely, in my opinion, it's not education, to simply put.
Yes, that's the hard reality. You know, there is no hide and seek here. And as you rightly said, other than NITs and IITs for technical education, I recommend only, you know, next to them, I recommend only the European universities. That's how it is. And what was your master program title? One more time.
It was called Computational Modeling and Simulation, right? So
okay.
I'll give you a basic idea of what that is. So basically, let's say you have a car, right? So make it very simple in mechanical terms. So let's say we have a car, but then you want to have, okay, so what sort of suspension do I need? What sort of powertrain do I need? So when you ask these questions, you have to do some mathematical simulations and calculations, right? So for the people who know it, it's basically the FEM, finite element, computational fluid dynamics, multi-body dynamics, all of these simulations. So my master's program was basic overview of all of these different types of simulations. So how can you get the concepts from mathematics? Because this comes from very deep applied mathematics. So you take the concept from mathematics, you apply it to an engineering concept, and then you implement it via computer science. So because you have to run these simulations on the computer. So my master's was let's say a holy trinity between all of these three disciplines, so to say.
Okay, interdisciplinary program, and if it is so, you know, it makes all the more interesting, right, and challenging also.
Absolutely. It's in fact, for me, the engineering aspect was good, the computer science was okay, but then when we had to do the applied mathematics, it's insane because the way the mathematicians think is completely different from what an engineer thinks and what a computer scientist thinks. And then the entire idea of the program was that you need to get a gist of all of these three disciplines, and then you actually are qualified. And that's the extremely hard part, looking at from a mathematical perspective. That was hard for me. But then some people who come from, because in my program, there were also applied mathematicians, right? So for them, the engineering aspect was hard because they were never looking at things at an applied setting. So yes, it's pretty challenging.
And we have spoken a lot about you, meaning with me and your mom. And I had little conversations with you. And I always feel, you know, you always try to keep pushing your limits, you know,
absolutely,
from A to B. And so these sort of interesting interdisciplinary or multidisciplinary programs combining several arrays of engineering, I think it's like a feast for you. Don't you feel so?
Absolutely. It's a feast, and it's also a requirement because considering the way the world is progressing, right? You cannot just stick with one discipline and say, this is all I'm going to do for the rest of my life. Because what's going to happen is maybe in 5 years, AI is going to probably replace you. Like, for instance, just to give you an example, if you just wanted to do front-end web development, it's going to be pretty much redundant in the next 5 years because you just ask, for instance, you ask ChatGPT to give you the code for a front-end page, it will do it. All you need is like some tweaks and you already got it. So you need to have this multidisciplinary approach to actually still stay relevant in the state of the art, so to say.
Exactly. And staying relevancy is what is the key. For example, when it comes to any industry, for that matter of fact. And before we talk into your further research activities, nowadays, you know, everybody is studying only artificial intelligence, data science, data analytics. And these students are even making fun of core engineers. You know, for example, I studied electrical and you are into now hardcore mechanical and mechatronics and stimulations and stuffs. And it's very surprising to, you know, for example, I may not be as relevant or as in-depth like you because you're currently practicing engineering. I am not. But if you tell me, whichever course it is, whether it's computer science or mechanical or psychology or environmental engineering, all has equal role in the society that we live today. And every subject should be given equal importance. And when I travel to, why I'm telling this, Tanuj, to you is, when I travel to all the top colleges across Tamil Nadu, Everybody is studying only artificial intelligence, data science, data analytics, machine learning, cyber security. Tanuj, mechanical, mechatronics, food technology, biotechnology, robotics departments are closed.
This is
the
sort of
reality.
I think it's basically following the trend, right? So because people saw that, okay, if you studied computer science, that was basically the boom. Like about 10 years ago, everybody saw computer science, Java, and everything was the state of the art, and then they just did that. And then everything else became irrelevant. So it's the same thing that I'm expecting that's happening now, where people see AI, machine learning and stuff, and then they just go on that path to completely disregard everything else. But this is not the right way, because the basis, for instance, I can speak because I was in AI. My master thesis was on state-of-the-art probabilistic machine learning, which is like something extremely state-of-the-art. And I did an applied project on that. And then one thing I can tell is, even though we have all of these fancy algorithms and machine learning, blah, 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 without understanding the basics, when you go and apply it to a real life concept, nobody wants to buy it. Nobody wants to buy. Okay, for instance, I had in my institute, I have a group leader who's a very good friend of mine, and he basically works with security for military and all of these special services, right? And they do not have one speck of AI in their group, simply because it's not trustable. So if you ask an AI to generate something, how do you know it's robust? How do you know it's safety critical and stuff like this, right? So it's a very good thing to have on the side, but it should not be the main focus. Also, another thing is, you cannot completely understand AI or machine learning without understanding statistics, linear algebra, and some basic mathematics. But if you can understand these three subjects, you could also go into engineering. So the basis of AI is just this one big, very nice, it has this very nice appeal, but in reality, you need so many other things together with it. So, and also, even though I did my master's and my thesis topic was on AI, most of the stuff that I do now is basic engineering combined with principles I learned from AI. That's all you need. I would never say don't learn AI, but I would say learn AI and machine learning and data science as a side thing that can help you with stuff. But then,
so obvious question, but still I would like to ask to give clear clarity to the audience. So where is your money on? Core, you study core engineering and take up all these things as a, tools or subjects, or just study AI alone? Where is your money on?
Absolutely, I would say the core subjects first, and then you add them as a tool. For instance, since I'm working in a research institute, we also have this obligation that we have to do a course or some sort of course every year, because I'm a scientist, right? Basis. I'm a scientist who's also doing a PhD, and I'm also working on real life projects, European projects. So the idea is, we have to do every year, we have to do 1 or 2 courses to show that we are still improving. And this is important. And the funny thing is, even though I have so many degrees in so many courses in AI and stuff, I'm still doing courses on control engineering, for instance. This is the course I'm doing. And when you look at control, this is the basis of electrical and electronics, ECE, basically. So this highlights the point again, that without knowing the basis, you cannot go into AI. You need to have, looking at an engineering perspective, you need to have some concepts of electrical, some concepts of mechanical, some concepts of other engineering, and then you can add AI as a supplement, which is only a tool.
Yes. I know, interestingly, Tanuj, the same is told by Anna University Vice Chancellor also. They will never run a program in artificial intelligence or data science or data analytics or machine learning. People watching this interview, they are most welcome to go to Anna University Guindy campus website. They will never find any of these programs. And they clearly state, we will never run these programs in any of our campus colleges, where we will teach these subjects as a tools, not as a program. That sums up.
Yeah, exactly. So you can have these concepts, 2 or 3 modules in a bachelor's program. And then once you decide that this is the specialization you want to make, then you take it up in your master's, or your PhD program. So when you specialize in AI or machine learning for your master's or PhD, then it makes sense because you have the basis and then you can develop off of that and you can do more state-of-the-art applications. But just looking at it from the so you want to start off with only this, basically narrows your scope down. And then this is the...
Yes, very, very clear explanation, and that too from a scientist and a researcher in Europe, currently into live projects and all with these public universities. And when you say all these things, that adds more value. That is why we spent almost 10 minutes on this particular topic. So I wanted to always ask you, even though I know the answer, this is just for the audience. I'm sure after your bachelor's, you could have picked up a job. And I'm sure after your master's, you could have picked up a job. But you are always getting back to learning. So talk to us about that.
I personally think once you stop learning, you will stop growing. It's only a matter of time. Once you stop learning, it's only the time bomb is ticking. So you might be relevant for the next 3 years. After that, without learning, you're going to become irrelevant, especially with the state of the art. So learning should be the number one, even though I'm a research scientist and I'm still looking for opportunities. For instance, the PhD program, something that I got onto, I'll have to spend sometimes the weekends also work for that, but I don't mind because I'm doing my work and also my PhD on the side. So
super.
Main objective is you have to keep improving your state of the art. If you're not staying relevant to all of the technologies here, it's over. It's over pretty much. Yeah. I think it's an absolute necessity if you want to get, and also this is something I would say to people who want to go to Europe. This is the mindset. In India, often the case is, okay, you finish a degree, you get a job, you stay there, you spend money. The focus goes on money. But in Europe, at least in the technological sector, the focus is always on being state of the art. What can I do next? How can I learn? So this is also a swap of mindset that you can observe between Europe and India, so to say.
Exactly. And to bring this mindset only, I'm doing all these interviews with super focused students like, you guys. And Tanuj, I got a comment where school children are watching these interviews, So
I think that's very good.
I felt exactly. And they're going to listen to you and they are listening to your life journey. How did you overcome and, how focused and how did you face all these challenges to be super successful? Then comes your PhD. And before I wanted to ask this question. Bachelor's, you did it in a different country. Master's, you did it in a different country. I was expecting your PhD to be in a different country, but you choose to stay back in Germany. Any specific reason?
The reason is pretty simple, actually, because my PhD is in Germany. You don't have a PhD where you do it only with the university, right? So you have like different scopes of PhD. What I'm doing is an industrial PhD, which means that my PhD is not very theoretical. What I'm doing is related to an actual project. In fact, I think you can look it up online. It's called the HiCom project, which is basically we're building a hybrid vehicle for construction machinery. And then I'm responsible for the powertrain development for this project. And this is the focus of my PhD. So it's not something I'm just writing. And for instance, we've already started procuring the parts and building the machine. So in the next year or the next second year, my program or my algorithm will go inside the machine. So it's basically like R&D for an actual physical vehicle. And this is the reason, once again, why I did my PhD here. And you might also think for a second, right? Because my master's was in TU Dresden, but my PhD is in TU Chemnitz. So only looking at the rank of the universities, TU Dresden is much better than TU Chemnitz. So why did I choose TU Chemnitz? You might have this question, right? And the answer... Yes, exactly. The answer is because TU Chemnitz is the university when you look at mechanical engineering and for alternative fuel cells. And they have a much huger connection. Even though the university, Dresden is much better in rank in compared to TU Chemnitz, you can never compare German universities like that. You have to look at what courses they offer and how proficient and how much funding they have in that particular course. And then you go to that university, right? And in that regard, TU Chemnitz's professor, who's my head professor for the PhD program, he was basically the R&D head, the technical director. He was the technical director of Volkswagen in China. And he has such a huge connection. So this guy is basically an engineer, very applied, research scientist engineer, and then he came to the university and said, okay, now I'm going to do European projects. So this is the main reason. So again, to answer the question, the reason in Germany is because Germany is the state of the art in Europe for fuel cell drives. And in Saxony, which is the state of Germany I'm in, TU Chemnitz is the best university for fuel cell technology.
Super. And before you could even answer, I also prompted the answer because topic decides everything. Forget about the world rankings. I'm sure Tanuj would have even chosen a university, even which is like, even, lowerly ranked compared to what you're doing today. If it matches your idea and your topic of interest, I'm sure you will pack your bags and go there. Topic decides everything, not these world rankings or all these things, which people don't understand.
Funding and how much research they have. Yeah.
Tanuj, a joke I want to tell you. Tanuj, I want to tell you, a funny thing. I got a call. I'll finish it shortly. I got a call stating that, sir, I got a PhD in UK. I was like, he was very happy. I said, like, okay, what is the funding? Sir, no funding. Then I was like, so for what for you're calling, sir? No, how to get a funding? I said, like, please don't waste my time. So people, Tanuj, you don't believe, Tanuj. I know you would have heard it. People spend from their pocket and pay for PhDs and do in UK and Ireland.
Absolutely irrelevant and stupid, plainly stupid in my opinion. PhD is where you contribute to science, which means that you need to get something. You cannot pay and contribute to science. That's not how it works.
Exactly. It's like you work for a company and you pay the company. தமிழ்ல சொல்லணும்னா கடவுள் தான் இவங்களை எல்லாம் வந்து காப்பாத்தணும். Only God can save them. And when they are not ready to listen, I don't want to spend even a single second of my lifetime in talking to these people. Nowadays, I am in a mode where I only answer for the questions they ask. No inputs, nothing. Because I don't want to talk to somebody who is not ready to listen or improvise themselves. That's how
exactly. Only when people want something, they can actually get input. You cannot force them to do stuff that is irrelevant.
So audience, please, if you get a PhD, it has to be only funded. But surprisingly, Tanuj, only in Schengen countries, by default, all the PhDs are funded.
Funny part is my PhD is not funded, but I am a researcher in IVI and I'm doing an external PhD, which means that my contract is to my research institute, which is Fraunhofer IVI. And because of this, I still get paid as a researcher. I get the 100% pay of the researcher, which is sort of, it's not the best salary in Germany, but it's one of the higher salaries in Germany. Exactly. And I also get the experience of being a researcher, and I'm also doing a PhD on the side, which is why my PhD will take a bit longer than regular PhD because I'm doing it on the side. But I really don't care because to me, this is a way of improving myself.
Super.
If you get a unfunded PhD, this is the case that you have to look for. If you're working in a research institution or if you're working in a company in the R&D sector and then you get an unfunded PhD as an external candidate, then it makes sense because you're also gaining the experience and you're also learning the science of it. But then if you only do this without any money,
no point.
It's absolutely stupid, yes.
See, either the PhD funds you or some other way or any other way, as long as your living expenses are covered and you're able to move forward, financially, that is going to be super. One more time, what is your topic of your research right now, PhD?
So basically, looking at the fuel cell technology, battery technology, and how we can integrate them into a powertrain, which means that a powertrain is basically the base of any vehicle. So the motors, the power converters, the transmission, all of that stuff, and then also the electrical components that go with it. And then my PhD is basically simulating the entire powertrain for this vehicle that we're actually building and to run some algorithms to make sort of better estimation and also look at how the system will degrade over time. So it's a lot of engineering, a lot of little bit of computer science, embedded coding, and also a lot of feasibility and optimization studies. So this is the topic. So to summarize it, you could basically say system simulation and powertrain development for fuel cell hybrid electric vehicles.
Wonderful, wonderful. I would like to ask you, you would have surely had this discussion among your peers. Do you see like hydrogen coming as a fuel?
Depends. Hydrogen is a very good energy carrier, but without the logistics, it doesn't make sense. And that is
Okay.
why what I mean to say is hydrogen has a very high energy density weight-wise, but it has a horrible energy density volume-wise, which means that you need to compress it so a lot, and you need to put a lot of energy into compressing it, right? And because of this, the entire cost of hydrogen is very high. What will make sense is if a lot of companies and a lot of money goes into hydrogen, and then we have a robust network of hydrogen supply. So if you have a robust supply chain, this will prompt the hydrogen technology prices to come low, right? And what this will do is it will encourage more people to start investing in this. And this is basically a circular economy. So at this point, even in Europe, hydrogen is only feasible for commercial vehicle operation. So when you have an electric vehicle, and then electric vehicles are good for short range travel and for low loads. But then when you want to do like an heavy load application, then electric vehicles become infeasible. At this point, you have to involve a IC engine. And this is where hydrogen comes in. So you don't want the IC engine because of pollution, and you swap it out with the hydrogen power drive, right? So this is the reason why at this state of the art, it's only feasible for commercial vehicle operation. But then maybe in the next 5-10 years, a lot of politicians, a lot of companies invest in hydrogen, and we build a very good supply chain, then I definitely see it becoming more consumer friendly.
Okay. Fast forwarding to 2035. So we have all this gasoline, petrol, diesel. Then we have this, electric vehicles. Then you have this hydrogen. What would you predict the percentage of usage?
I would say I'm not sure of. I don't know too much about the because I'm pretty sure there's also a lot of economy and a lot of let's say funded or not funding. What I mean to say is a lot of lobbying around the diesel fuel and all these conventional systems. So I cannot say how long it will stay and how things will go. But as far as hydrogen goes, I definitely see it becoming one, because it's not a trend. If you look at India, even India is investing a lot of money in hydrogen. Just in Chennai, I think, 100%. Right? They made a new train, like ICF released, basically had a research project with the hydrogen train, right? So a lot of countries, not only India, China, Europe, US, all of them are investing in hydrogen. And the reason for this is very, very simple. Hydrogen is something you can generate out of nothing, right? So all you need is water. For instance, electrolyzers are a huge part of European projects. It means that they will put a lot of renewable energy and they won't store it. They will convert it to hydrogen and use it to basically fuel your needs. So essentially, think about it, you can create hydrogen with only energy. So it's like a battery which has no limit. As long as you have the enclosure for it, you can pretty much have infinite amount of energy.
Excellent.
So
excellent.
This is I see the key point. So in the future, I see a lot of renewable sources producing a lot of hydrogen. We have, in fact, even in Europe, we have gigawatt scale projects for hydrogen electrolyzers. For instance, in Saxony, there was a company, I don't remember the name. They just recently installed a 1 megawatt hydrogen electrolyzer. That's a lot.
1 megawatt. Okay.
1 megawatt. Yeah, it's a massive scale electrolyzer project, like multiple stacks. So this is the key. I say you generate the excess energy and then you convert it. So this is the key point I see winning over fossil fuels. Whereas you have fossil fuels, which you just keep extracting. At some point, it becomes harder and harder, because every time you extract, you have to go deeper and deeper, right? And this makes it much harder. Yeah. Exactly. So I see it decreasing in value with time, and I see hydrogen increasing in value with time. But how this thing changes, I'm not, because I'm not an economist. I'm a research scientist. Yes, exactly.
Yeah, and Tanuj, many young engineers would love to ask me this question to you. Forget about your specific department. In general, some upcoming topics which if students could study, it will be really useful under the engineering domain. Something you could name?
Some things I would always stick with the basics, right? So basics, mechanical, mechatronics, electrical engineering, all of these, the principles from all of these can be exchanged and interlinked with everything. So stay with the basic, but don't just study the basic. Add whatever you can from state of the art. For instance, if you're like a control engineer, state of the art is model predictive control and machine learning based control. So they take disciplines of machine learning and they apply it to control engineering, right? So this is something I would say. So it's the basis, at least when you look at engineering, just because we are going doesn't mean Newton's law doesn't hold true, right? It's been there for hundreds of years and it will also be there for hundreds of years, right? So you can simply not disregard the basics. So what you could say is any degree which has mechatronic elements, electronic elements, electrical elements, embedded elements, engineering elements, study that, but then make yourself relevant in that state of the art, which means that even if the university is not offering courses, you have to have the knowledge to pursue, okay, what is the state of the art? Look, there's so many courses available online. There's so many state of the arts. There's so many talks about how the technology is developing. So update yourself. So keep the basics, update. So that's what I would suggest. So looking at it, I would also go back, and even if I started with electrical engineering, I wouldn't mind, because if I started with electrical, now I'd be studying mechanical. I started with the mechanical and now I'm studying control and electrical. So the basics are always relevant.
So the point is very simple. At bachelor's, same like Tanuj, take up whether it's electrical or mechanical or mechatronics and all those things. Then specialize or specialize at the PG level, but parallelly keep learning all these new techs to support your core engineering. Correct?
You don't even have to learn them by doing a course, but just keep an eye open. Like, okay, what's the state of the art happening? What is relevant? Because before you can study something, you need to know what you have to study and what is relevant and what is state of the art. And exactly. This is the most important thing.
Yes, and what all new state of art that I can apply from core engineering concepts. Yes,
absolutely, I would agree.
Super. I learned a lot of things during this interview, man. Looking at looking at you as a 17-year-old boy, asking a lot of questions regarding UG, and now you talk
it's
of
about
all
10 years
technology. See, it's a transformation, and one thing which I am sure about you, which I can tell to the audience without your permission, this guy will always keep pushing the limits, and I am sure with Tanuj, every 5 years, even if I do a part 2, part 3 also of these episodes, we will have a lot of new informations. Wonderful.
It'll be pretty interesting.
Taking time out. Thank you, Tanuj. Even though we are like, kind of family friends, but still for you to take time out on your weekend in between your busy schedules, thank you for doing this. And also, I want to ask you this. Let's keep this engineering thing aside. Okay. So, by the way, audience, Tanuj is a fitness freak also. And plus, what are your other hobbies? How do you keep yourself balanced? Because all the time you cannot keep studying, right?
Yeah, you cannot keep studying or working. Oftentimes, for instance, I'm really into kickboxing and Muay Thai.
Okay.
And I'm also, like, for instance, I was doing kickboxing when I was studying in the university. So, the university offers kickboxing courses, right? So I've been doing it for like 5 years, for the past 5 years now. And the old coach went away. So I'm also teaching the kickboxing course at the university. So this is something, and then sports as well. So for me, health is one thing I realized is I wasn't always this fit. I like to highlight the point. I was very unfit at some point, and I realized how much of an effect your fitness has on your mental ability as well. So I would always put fitness and the willingness to learn, knowledge and physical fitness, or they go hand in hand. Yeah, you cannot just be reading, studying all the time and disregard your physical health as well. Right? So
it doesn't take us anywhere.
Yes, exactly.
It doesn't take us anywhere.
Absolutely. So I also do kickboxing. I also do a lot of running. I do hiking. I have like a very nice bicycle. So I also go on very long bicycle rides, 60, 50 kilometers easily sometimes. And usually, and that is also the reason why usually it's not, I pretty much don't have any time at my home. I'm always running. Like, for instance,
your plate is full.
Yeah, absolutely.
Good. And, really happy. I learned a lot of things, but with your permission, I would like to say, surely after 5-6 years, we will do a part 2 of this. By the way, when are you finishing your PhD? Which year?
As of now, I just started it officially, but then it is planned for the next 3 years. So I would say maybe 28. But then in case the project, there's some problems in the project or the funding problems, then it might have to get extended 1 or 2 years. But definitely within the next 3 or 5 years, I see myself doing it.
Super.
And
I would.
then
I'm waiting for the moment where I can call you Dr. Tanuj. Hello, how are you? I'm waiting for that.
although, for instance, I already had like 2 papers published, but my professor wants like at least 4 or 5 papers, and then based on how I can corroborate it into a thing, it depends. So I really never know, but let's say 3 to 5 years
Super.
to keep it.
Super. 2 last questions before we sum up this interview. So, how happy your mom and dad are looking at all your progress?
They are pretty happy, but they're also a bit worried because I don't get to talk with them too often. And like you can talk with them, right? And you can ask them about me, right? And then they'll pretty much say like he's always working, I never get time to talk with him, I never get but I think that's a trade-off. I still try to make time. For instance, after the call here, I'll probably call my mom and talk, or my dad and talk, but then it's often pretty hard in the sense that to spend more time with them. But then in terms of progress, they're really happy. And then they often tell, I also have a brother who's also studying Germany.
Yes.
And then they often tell that,
I know.
Look at Tanuj, be like him. You need to push. And then always referencing me to him. So they're pretty happy, I would say.
Excellent, man. I'm also really happy to be a minuscule part of your journey to start up with all.
But then you are the one who started it, so
thank you.
I'm gonna say yes. Probably even if you weren't there, I would have spent some time, and maybe I would have studied in these so and so engineering colleges and still ended up here. But this journey would have taken much longer for me. So I really appreciate the fact that the call that we had 10 years ago, or you said like, okay, come here, let's see if it's feasible.
Brother Tanuj, all credits to your mom and dad, and special credits to your mom. She was always proactive. She used to ask me, what about this? What about that? All those things. And as a mother, she was always trying to give the super best for both of their children, basically. Absolutely, and yes. You guys are making it count and setting really high standards for people to
try.
You're being very humble, man. Wonderful. And keep moving and keep pushing your limits anyway. You're going to do that. So before we sum up this beautiful interview, any few last words, for youngsters, especially watching this interview?
For instance, what I would say is always be curious. Always keep learning. Money, don't search money, because money, a lot of my friends, right? I'd like to say it, even when they studied masters, they did not focus on the course. They started focusing on money. They started doing a lot of these part-time jobs, so to say, non-technical part-time jobs. So don't focus on that. So don't ever go around money, right? So always, if you get a part-time job, like me, when I was a research student in the institute, which is how I did my master's degree there. And I also got into as a full-time researcher, right? So if you get a part-time job which gives money, which also is technical and relevant to your field, then go for it. Absolutely, 100%.
Why not? Why not?
Yeah. That is really good. But if you just have to do something like, for instance, I don't know, like doing some delivery services, looking at working at like fast food chains, don't do that, because that is very bad. So don't chase money, chase knowledge. Always focus on yourself. Try to make yourself better. And then people will come to you offering money for your solution. If you start searching money, you will not focus on improving yourself. At one point, you will get replaced and become irrelevant. So always focus on improving yourself. And the more you improve, the more your worth increases. It's like investing. You invest in yourself, invest in knowledge, you become more and more worthy. And you don't even have to go for work, for instance. So even now, I work in a contract basis, right? But I already have been to multiple conferences. I have lots of connections with lots of industries, right? So even if they say, okay, unfortunately, we can't extend your contract, I have like 10 other people I can text in the industry. You can say like, I would like to join. Is there any opportunity? And then if there is, I could easily transfer. And this is in Sweden, it's in Austria, it's in Denmark. I have based on conferences and technology exchanges. So invest in yourself. That's the on thing. always keep learning, stay relevant, invest in yourself. Don't go looking for money. Invest in yourself, and then the money comes looking for you.
Exactly. And when I ask the student, what's your major aim of going abroad? When he says part-time job, then I end the counseling session. Thank you so much. You have come to a wrong place. That's how it is. Thank you so much, and wonderful.
Absolutely.
And great talking to you. I learned a lot of things. And on behalf of the students and parents and audience watching this interview, thank you so much, Tanuj. I'm not telling this to boost or anything, really inspirational. You are pushing your limits. I could say easily, define in my 16 years, if I had to call like, top 5 students, you are over there. Simple reason, brother. Simple reason is you are pushing yourself to the level best, limit best possible, and that's going to take you to places. And excellent. Thank you so much, and I'm very happy. And thanks for
Thank
your
you
time.
for helping me out with that. Yeah, absolutely. I know
I am just 0.001%. That's it.
I know to get this meeting, we had to talk like multiple sessions, like if it's possible, but I'm really happy that I was also able to be there.
Sure. And we will do surely a part 2 after your PhD. That session will be
definitely.
Only about
it would be like to see. I mean, just to give a thing. So right now, even now, right, I'm already getting involved in EU proposals, which means that I just was talking with my boss, and he just told me to sign up to be in the EU committee for certain technologies. So for hydrogen technology. So maybe, and then I was already involved in a proposal. Just yesterday, I had a meeting for a 5 million euro project proposal. And then basically, when you look at me, I'm basically the most junior guy there. I'm like with 3 years, 4 years of experience. And the other guys are like the CTO of a fuel cell company, a senior principal engineer who's with 15 years of experience. And I'm already getting to know them, which means that I really enjoy also the organizational and then the this level of something learning new as well. So that's what I would like to say. Don't ever say this is not for me. Always learn. If you want to do it later or not, you can decide later. Get into it. So maybe in the next 5 years, I'm not even in the technical side. I go more on the organizational side, but you never know how things will.
No, you never know. Yeah,
exactly.
It's all about getting uncomfortable and pushing the limits forward.
Absolutely. You can never stay complacent. You need to stay uncomfortable, because if you're comfortable, there will never be growth. Put yourself in a new position, get uncomfortable, adapt to that, go to the next. Improvise, adapt, overcome, always.
Wonderful, man. Thank you so much.
Right.
And
thank you so much.
Excellent. Thank you so much, and see you very soon. Take care.
Absolutely. Next time I'm in India, I'll visit you.
We'll catch up. Yes, we'll catch up.
Yeah, absolutely. Have a nice evening. Cheers.
You too. Bye-bye.
Bye.